identifying the start and the end of the base unit of either a sine function or a cosine function on a sinusoidal graph like this can, however, be quite challenging sometimes due to the fact that many online assignment softwares out there in these days are giving graphs where the resolution is not so high, or graphs where it is hard to recognize the grid spacing. For example, in a current online assignment like this, somebody can randomly run into a problem where the graph is making it hard to recognize how big the space between two vertical grids like this. And of course, they are equally spaced, but it's hard to recognize how big that spacing here. But in any of those problems, no matter how challenging it is, there will be a clue for us to find out. And so right here in this particular problem where I'm bringing up, where the graph, admittedly, looking by the eye, is hard to recognize where these peaks, what is the x value of these peaks here, but we can rely on the scaling here by, well, 1 unit from here to here has a label being a, for here 0, and here is a pi over 4. And it looks like there are 3 equally spaced grids in between those. And the same thing with that next space here from pi over 4 to pi over 2. There's the same 3 equally spaced grids inside of that. And so in that way, it looks like from where our main label scale being a pi over 4, then each of the little square can be just simply a pi over 4 divided by 3. And what I mean is each of the little space right here between the grids where the graph fails to display the label, then each of those is a pi over 4 divided by 3. So the space there in each of the, between each of the little grids is a pi over 12 spacing. And that's making it easier to now to recognize. Now we have a proper scaling even if we don't have that being shown on the graph. And furthermore, it's also challenging on this graph in a sense that these peak points of our sinusoidal graph happens where, and this is caused by the not so high resolution that I set right here, where it's not too clear to our eyes where the peak here is happening exactly in the middle of the grid or not. But yes, rule of thumb, we can see that this graph is trying to describe a bottom peak that happened exactly between the 2 points here. And you can see that these 2 points where the sine graph cross through the center line, then these 2 points are exactly on the grid. And so rule of thumb is that peak always happen exactly in the middle. So here it has to be exactly in the middle of that spacing here. So if somebody is asking me a problem like this particular graph, I would say it has an amplitude being 2. It has a center line being at y equals 2. And if we decide to write this function as a sine function, then it needs to have the coefficient 2 in front and plus 2 according to that center line being found at y equals 2, and with the amplitude being 2. And all we need now is just like how we've learned in the earlier video lessons. Then we just simply need to recognize our base unit of the sine wave here. And I can just go from, I can choose my sine wave base unit to start from here and end here. And this start point here now is with our understanding of the base unit. So for this current graph, each of the little square, each of the little space here between the two subgrids is a pi over 12. So from here to here, it's going to have to be a pi over 6 space. And so I can see that my start on the base units is an x equals a negative pi over 6. And in that way of how I'm arguing it, then let's look over to the other side where it ends right here. Then it seems like we got 1, 2, 3, and 4 little space like that. And so it seems like it's going to end at the end of our base units there is at pi over 3. And so that means immediately into our function here, it has to be an x plus pi over 6 here. And for period, we can easily take the end of our base units that we recognized minus the start being negative pi over 6. And calculation comes out to be pi over 2, which gives us our A value here to be, and allow me to be quick here, but this is going to be 4, as it could be the standard periods over 4 to give us that total periods being a pi over 2. And so that means we can put our coefficient here being a 4 inside of our sine function. The same function there, but if we want to recognize that as a cosine function, then once again it has to have the amplitude 2, which is we're putting now a coefficient 2 in front of the cosine. The center line is at 2 again, so we're going to need to add 2 after the cosine function. And what's waiting ahead now is to how we can identify the start and the end point of our base unit on the cosine function, and then formulate that as an expression inside of our cosine function here. And so in that case, it looks like, and I can choose my wave to start here and end here, my base unit of the wave start here and end here, or another one from here to here. But keep in mind again that this peak right here, even though the resolution is not too clear, but it's supposed to happen exactly in the middle between the vertical grids right here. So our starts must be at x equals, I choose this point where my mouse cursor is, I choose x equals negative, but this is now really pi over 24 because it's actually halfway. Remember, I made my argument earlier that in this particular graph, then the spacing here is indicating each of our vertical grid here stays at the space being a pi over 12 apart from each other. And so now that makes sense. My start on that, my start point on the x value here has to be at negative pi over 24. And then on the other end right here, that it has to be calculations show it should be 11 pi over 24. Or we can think of this as a quick note right here. Up to this point, it's a 5 pi over 12 from where the y-axis out to that, and another pi over 4 added. I mean another pi over 24 added to that, and that's how it has that ending at 11 pi over 24. And so now immediately we can go back to our cosine function and formulate that expression inside being x plus pi over 24. And what's waiting for us now is the coefficient A, which relates to the periods. So let's now find the periods here. Once again, the periods for our function. If we want to recognize that as a cosine, then 11 pi over 24 as the ending of our period, subtract negative pi over 24. That, after calculation, comes out being altogether pi over 2. Which shows that my A has to be 4 due to the fact that standard period 2 pi over 4 will equals pi over 2. and pi over 2 is our current period for this function. And that means, back to this coefficient a now, it can be changed to 4 there. So as a cosine, our sinusoidal graph can be identified as 2 cosine of 4 in parentheses x plus pi over 24, close parentheses, close brackets, plus 2, or it will be 2 cosine of, distributing that 4 into each term here, I'm looking at 4x plus pi over 6 in parentheses plus 2. And here is another one where the online homework assignment on some commercial software out there can potentially cause some challenge in terms of recognizing the peak points and where the base unit can start. It's a sinusoidal graph, admittedly, but the grids here are not so well displaying it. The spacing between the grids are not so clear to recognize how much the space between the grid is. And so consequently, it's hard to recognize these start and end of a base unit. So here's the clue I can see right here. And once again, so every problem has their own clue for you, even though the labeling of the spacing is not so easy to recognize, or in other words, even though the spacing between the grids here might be a little hard to recognize here. But so on this particular graph here, what I can see is according to the spacing provided by the graphing device, then we have a pi unit right here. A pi is right here on one of the grid, on one of the subgrids right here. And so from 0 out to that subgrid, let's say we have, there's a 3, 6, and 9 subgrids. So that means the space between any two vertical subgrids here has to be a pi, but over 9, because there are 9 little subgrids right here between them. There are nine little small spaces between them. And once again, from that point on, you can see that anytime it looks like here we have a sine wave, and our sine wave will start at somewhere on a grid and end at somewhere on another grid here. Any of the peak here happens exactly in the middle between units of 3 little spaces like this. So that means this has to be exactly in the middle again, even though the resolution is not too good for us to recognize. And so I'm not intending to go completely into how to solve this problem, but that's how I can point out that so that little amount of space between the x-axis out to that high peak right here has to be a pi over 18 on the x-axis.